Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. What I want to do is I want to create a cube calculator, but I want to do that using classes. So I wanted to go step by step to show you how in Visual Studio to create classes. Well, the first thing we have to do is we have to start off with a header file. So what I'm going to do is I already created the project. I'm going to go to the Solution Explorer. And I could either right-click on source files, or if I wanted to keep all my header files in the header file folder, I could also right-click on this as well, click Add, and then I'm going to click New Item, and then that allows me to select either C++ or header file. Well, the first thing I'm going to do is to select the header file, and in this case, I'm going to select, or type rather, cube. So this will be the cube.h file. This is the header file, so I'm going to click Add. And now it's ready for me to type in the information. Well, the first thing I'm going to do is I'm going to type in the word class and then the name of the class, which in this case is cube. Open and close bracket right there, or curly braces. Now I'm ready to go. The next thing that I'm going to do is I'm going to type in public, colon, and private, the colon there. So these are the two sections here that I need to work with. Well, when it comes to a cube, really the primary thing that defines the volume and the surface area for a cube is going to be its side. So I think what I'll do over here is I'll just say double side. That's going to be the private instance variable. No one has access to this because it's under the private word. So now, or the private section, I should say. So now what I'm going to do is I'm going to create those functions that will allow me to do the following. So first of all, I want to be able to get that volume, or get the side, I should say. So that's going to be returning a double, and we'll call this get side. And it doesn't receive anything because I'm just simply going to be obtaining what that side value is. I'm also going to create a void function called set side. And what this does is it will, if I give it a number like, say for example, if I give it the side parameter, it's going to assign that to the private instance variable side. I'm going to go through all this throughout the video, so I'm just typing stuff down really quickly while it's on my mind. Another thing that I want to do is I want to be able to calculate, so we'll say calc, the surface area of a cube, and I'm not going to give it anything. I'm also going to want to calculate the area, the volume rather, the volume of a cube. I also have to create the constructor, so I just simply type in cube, open and close parentheses, and then I also have to consider an overloaded constructor as well, so we'll type in cube, and I send you a side parameter, and you can do something with that. Once you have the side parameter value, you can calculate all these items that I want. Okay, so just to remind you, these are called constructors. So this is a constructor. And what the constructor does is it's the first thing to execute when you instantiate the program. Before anything is displayed, before anything is performed on your program, this is the first thing to be called before we perform any type of calculation. All right, so I think that takes care of my header file. Now I'm going to create an implementation file of this header file, so we're going to call that cube.cpp. So over here in the Solution Explorer, I'm going to right-click on Source Files. We'll say Add, New Item, and this is going to be a C++ file. Specifically, it's going to be the cube.cpp file. All right, so this is the implementation file. Let me take this guy and move it over here so I could split the screen, show you what that looks like. Well, the first thing I'm going to have to do is to include any of those libraries that I need. So we'll include iostream.h. Say, for example, I'm also going to include this cube.h library because that's how I'm able to create the implementation file. And over here, what I'll do is this. Let's take a look at this first method, or this first function here. I type in double, and what you're going to do is you're going to type the name of the class, which is cube, 2 colons, that's called the scope resolution operator, and that's going to show you all of the tools that you have access to, namely all these tools over here. Well, I want to work with the get side function, so I'll type in get side, open and close parentheses with curly braces. All right, so in terms of getting the side, really that just simply means this: return the value of side. So since this thing is private, I need a public way of being able to get this variable. And that's what this thing does. GetSide will return whatever that value happens to be. Okay, so now I'm going to work with setSide. So over here, let's see, that's a void function, so I'll type in void. Now this comes from the cube library, colon, and now I want to work with the setSide function, so that's this guy over here. So the scope resolution operator gives me a listing of all the members for that cube header file, so I'll just simply double click over here. Now notice this thing, you have to give it a double. So I'll put parens double, and over here I called it side parameter, so we'll be consistent and call side parameter over here. All right, so what does this thing do? It sets the value of side based on what was given over here. So I'm sending you this. I intend for you to put this value into here. Well, I don't want to do that if you've given me a negative value. So if side parameter is greater than 0, okay, fine. I will set the side to whatever you just gave me, the side parameter. But if you didn't give me something that's greater than 0, then I'm just going to set the side equal to 0 because you give me some sort of a negative number or inappropriate value. I'm not going to let you get away with that. And so that's the beautiful thing about creating private instance variables. You can control how they are being set or assigned whatever value. Okay, so now let's work with this guy over here, calculate surface. So over here, I'm going to say double because that's what this thing returns, double, and then I'll say cube, colon, I'm looking for calculate surface, there it is, and in this case it looks like it doesn't have any parameters, so I'll just simply open and close the parens, put a curly bracket over here. Alright, in terms of calculating the surface, what I'm trying to return is the surface area, that is. Well, let's go back over here to the web, and let's see here, for the surface area it looks like it's 6 times whatever the length of the side is, squared. Okay, so this is going to be 6.0 times, and what is it here? A squared, or the side squared. So I'll just use the POW function, and I already know what the side is, and then I'm going to say squared according to the formula, right? 6a squared, 6 times a squared, which a is the side. So that's how I calculate the surface. Now let's go ahead and work with this calculate volume. All right, so double, sorry, I meant to do that over here. This thing is going to return a double, and it's from the cube header file, and that's going to be calculate volume. Again, I don't give it anything, as you can see, in terms of parameters, and then I can go ahead and place my open and close curly brackets here. So what am I going to return? Well, let's see here. Do I have a tab for this already? Yeah. Volume is equal to whatever the side is cubed. Okay. So I'm going to return the volume cubed. So whatever the side value is cubed. So that's 3.0. So what this thing does is to simply cube the side, and that's going to return the volume. I have this taken care of. Now let's take care of the constructor. Okay, so over here, I just simply type in cube, scope resolution operator, and it's this constructor that I'm going to be dealing with, namely the default constructor. I want to make it so that when I instantiate a cube object, the side is going to be set to 0. Now, if I wanted to change that in some way, if I wanted to instantiate an object but give it a side of 1, 2, 3, or whatever that happens to be, then I had better overload this constructor. So over here, what I'll do is I'll say from this cube header file, again, it's the cube, it's this constructor, this overloaded constructor that I'm trying to access. So what I'll do over here is put parentheses, double, side parameter, and put an open and close parentheses over here because this is the one that I'm trying to get access to. Well, if you're going to give me a side parameter, I want to make sure it's a valid value. If you're giving me a negative number, that's invalid. So if the side parameter is greater than 0, okay, I will go ahead and assign side by private variable over here to side par. But if that's not the case, then I'm just going to have side be assigned the number 0. All right, so let me save everything. It looks like I've got my implementation file. I have my header file. So now I'm ready to create a main program to utilize this tool that I've just created, this class called Cube. So over here in the Solution Explorer, I'm going to right-click on Source Files, add a new item, and this will be a C++ file. Source.cpp is fine. I'm going to go ahead and add. Now let me go ahead and do this and split the screen so that you can see what that looks like. So here's my cube.cpp file, and over here I'm going to say include IOStream. I think I'm also going to include the string library as well. And I'm also going to include this header file, namely cube.h. So parenthesis, quotation marks, sorry. Cube.h, there it is, right there, that's the one. So if it's a user-defined header file, this is how you access it, through the open and close quotes. All right, so now what I'm going to do is say using namespace std, so I can work with cout, int main, and I'll put an open and close braces over here. We'll put system pause, and then return 0. So that's the standard stuff that we've worked with in our programs. All right, let me instantiate an object of type cube. So I type in the word cube, and let's go ahead and say, let me see, what should we do? How about box? Box is a type of cube. Now, notice that I didn't give it anything, so if I were to run this program, it doesn't have any initial side value assigned to it. Let me go ahead and create another cube, and let's say that this is going to be box 2, but in parentheses I give it a side value of 2.0. All right, so in this case what's going to happen is when box 2 is instantiated, it's automatically given the side 2. Over here, this thing didn't have any particular value assigned to it. So what does the constructor do? When the constructor is called and it says, hey, you created a box, you created a cube, but you didn't give me any value, so I will automatically set the side to 0. Over here, it says, oh, you want to give the side an initial value, so that's this guy over here. You gave me the number 2. Is 2 greater than 0? It is? Okay, I will change the side, which at one time was 0. Now I'm going to have it make it to assign 2.0 to that particular variable. All right, so let's go ahead and cout, and I'll say enter the side value. Okay, so I want the user to enter a side value, and we're going to put that into box dot. Notice what I'm doing over here. So I'm going to, whatever that value happens to be, actually, you know what, let me do it this way. Before I do that, let me just create one more variable over here, and I'll say int side. All right, so this right here is going to represent the side value that's going to be inserted by the user. So we'll say side. Now that I have this, for box dot, I can set the side like this. Parentheses, it expects me to give it a double. Oh, I said integer. That's wrong. I should have said double. So let me change that to double. All right, so now I can give it the side. And the side value is that which was inserted by the user. Enter a side value. The user did that. Let's give this to the function setSide, which belongs to this box object. Well, once that has been established, I can now calculate the volume and calculate the surface area, because that's exactly what I've been able to do over here with these two functions. Okay, so I can cout the surface area for the cube is, and let's go ahead and display what that surface area is. Okay, so box is the object, dot, I could say calculate surface area. What do you need? You don't need anything. Open and close parentheses. Okay, so then I'll just put endl over here. So what this thing does is it returns the surface area, and it's going to display it via the cout statement. Let's create another cout statement. We'll say the area, the volume for the cube is, I'm going to put a colon there, like that. And what that's going to be is a call to, within box, I have calculate the volume. And again, open and close parentheses because it doesn't require any parameters. After this, we'll put endl. Okay, let's see what happens. Let me go ahead and save the program. Let me run it, build it. So far, so good. Okay, let me just type in a really simple small cube 1. Okay, the surface area of the cube is 6, which is correct because the cube has 6 sides, and so 1 plus 1 plus 1 plus 1 plus 1, 6 times, that's 6. The volume of the cube is 1. That's correct because 1 cubed is 1. So that works out. Let's try it try for the number 2, say for example. So 2. All right, so the area, the surface area is 24, and the volume of the cube is 8. So we're looking good. And I can also accommodate real numbers. For example, if I said 2.2, okay, so there's the surface area, there's the volume. All right, so that's how you would think about creating object-oriented programs. You create your tools first, your header files, your implementation files, and then you create the source file that is going to be acting upon those tools that you just created. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.